Yeah, we can start. Yes. So hope my screen is visible. Good evening to everyone. I am Saravanan, PhD scholar and Prime Minister Research Fellow at Department of Civil Engineering, National Institute of Technology, Tiruchirappalli. So those who are joined today new, I'll just give a brief intro about me. So yeah, I did my BTech in Civil Engineering from Government College of Engineering Bodi and my MTech from Anna University College of Engineering in 2021 through GATE score, and I have joined my research program in National Institute of Technology Tiruchirappalli in 2021 July, and I got Prime Minister Research Fellow in 2022. And as a part of deliverable, I have to take 2 hours of NPTEL lecture every week. So I have chosen plastic waste management course in NPTEL. So this is our seventh week in the session. So our session will go in a manner like first 1 hour we will discuss about the lecture course material, and then another 1 week we are going to discuss about the old assignments of 2021 and 2022. Yeah. So we'll start this seventh week lecture. This PPT is made by Professor Rajesh Kumar Dubey sir of IIT Kharagpur. All credits to him. Yeah. So I'll make him to. Sorry for the technical glitch happened last week, and if possible, I will record the sixth week's session again, and I will post in the YouTube. I will remove the old video and I will post it again, because I was in IIT Madras and I can't get proper Wi-Fi and classroom for that. Sorry for that. And this week we are going to discuss about alternates alternative materials for the plastics. So first week we have discussed about what is plastic and what are the ingredients to manufacture the plastics, and what are the production techniques and its uses and its global statistics. And then the second week we have discussed about how the plastic waste is generated, what are its source, and how much quantity it was generated in India and worldwide. In the third week we have discussed about the plastic waste management rule in India 2016, and then other global rules and regulations on plastic waste. Then in the fourth week we have discussed about the plastic ban, single-use plastic ban and other type of plastic ban worldwide, and then China's national SWOT policy 2017 and its impact over other countries. And then in the fifth week, we have discussed about the impact of plastic on marine life, ecosystem, and human health. That's what we have discussed through some of the videos. And then in the sixth week, we have discussed about the plastic waste management practices, how to manage this generated plastic waste, like recycling methods, feedstock recycling, then pyrolysis process, and then mechanical recycling. Finally, through fat is a biodegradable, then we are discussed about composting and all. And then finally, some of these research are going on use of plastics in the plastic roads. And then this week we are going to discuss about the alternates to the plastics that we will call as greener alternatives, because that may this term green we are going to discuss this week. What this green means? Is it really green? How can we? What are the metrics to denote a material as a green material? Yeah, that's what we are going to discuss this week. Yeah. So this is what we have discussed. The green plastic. The plastic may be green if the source of raw material will be from a renewable source. It is not through any petroleum byproduct. It should be from any natural resources or any renewable resources, and it should be biodegradable or compostable. We are going to discuss about the difference between biodegradable and compostable, and then the green plastic should be environmentally and it should have an environment friendly manufacturing process. Yeah. And this green plastic was widely published worldwide, and now the production and use of bioplastics and green plastics are blooming. This compostable plastics is a term. It should, whenever the plastic that meets the standards mentioned in the European norms of EN 13432 and the US norms of ASTM, these are the codes we can refer. As India, we are having BIS, Bureau of Indian Standards, like that. European Union having European Nation EN standards, and USA is having ASTM codes. So if it passes the standards mentioned in EN 13432 and the ASTM D6 400, then it is called compostable plastics. Yeah. So, as per ASTM code, there are three criteria we need to satisfy. First one is mineralization. If a plastic will undergo 90% of conversion into carbon dioxide and water and biomass through action of microorganisms, then it is called biodegradable. Yeah, if it is degraded 90%, then this plastic may called as green plastic or compostable plastics. And then this degradation rate should be same as that of normal organic waste. If we put any food waste in the compost unit or any digester, then it should degrade within a stipulated period of time. The same rate it should follow. a plastic may undergo 90% degradation in 1,000 years or 5,000 years, then it is not called um, green plastics. It should degrade 90% within a stipulated period of time. That period also mentioned 180 days or lesser. So if it satisfies all this condition of mineralization, then it is called green plastic or compostable plastic. Then the fragmentation. It should not fragment more than 10% of its original dry weight, and it should pass through 2 fraction sieve. So after some period of time, if it not degrade, it's not degrading, but it is only fragmenting, then it is not called compostable or green plastic. Then its final one is like environmental impact. Whatever the impact caused by this green plastic in the flora and fauna should be negligible. There should be no negative impact on flora and fauna. So if it causes all this condition of mineralization, fragmentation, um, sir, Samyadeep, can you please maintain some decorum in the public forum, please? Yeah, thank you. So, if it follows all these three conditions, then it is called green plastic or a compostable plastic. Yeah. So here comes the difference between biodegradable and compostable. So all the compostable plastics are biodegradable, but all the biodegradable plastics are not compostable plastics. So biodegradability may have different sectors. It may be compostable, it may be anaerobic digester, or it may be any other forms of degradation, but not only through composting. So composting plastics are always biodegradable, but biodegradable plastic is not always compostable. That's what the first line says. Compostable plastic is a subset of biodegradable plastic that will decompose in the condition and time frame during the composting process. So we can say some plastic that is compostable as biodegradable plastic, but not all the bioplastics are compostable. That's what the code says. It's from a code. Definition is from the code. Yes. So here comes the term bioplastic. So the term bioplastic does not refer solely to biodegradable or compostable. It can be, it should be applied only. The raw material is the petroleum based plastic that is degradable, and plant based plastic that are not necessarily biodegradable. So two terms it can be defined. Bioplastics are maybe having petroleum source, but it should be degradable, or it may be from any plant source but not necessarily biodegradable. So the chart we are going to see in the upcoming slides that denotes what are the different types of bioplastics. So two terms are there. One is through the raw material, one is through the degradability. So raw material is from petroleum source or any plant-based natural source, and degradability it may be necessarily degradable or not necessarily degradable. So two terms are there. We can club this four items and we can define the bioplastics. So petroleum-based degradable, plant-based not degradable. Both can be called as bioplastics. So essentially, bioplastics are bio-based, biodegradable, or both. Any one should be there. It should be degradable, or it should be from any plant based, or it can be both. That's what bioplastic means. Yeah, hope it's clear to everyone this definition of bioplastic. uh, Percentage of plant based or petroleum based, that is not defined clearly. In one code it's mentioned 90%. 90% of its own material is from plant based or any natural based, then it is called bioplastics. Or 90 percentage of petroleum based plastic that is degradable in 180 days, then it is called bioplastic. So both terms we can take as 90%. Yeah, 90% is the average plastic. Sorry, average percentage. Could you repeat regarding bioplastic? Yeah, please. I will. Can I go to the chart directly? Then you will be clear. I guess. Yeah, I will go to the chart. This is the chart. So we have degradable, non-degradable. That may be biodegradable. I am talking about. And then renewable resources, petroleum-based raw material resources. So two terms are there. Renewable resources in the sense of plant-based or any renewable-based raw material. Here petroleum based raw material. So in this the y-axis is discussing about that. Then the x-axis is discussing about degradability and the non-degradability. So where is the bioplastic? This um, this quadrant discusses about something which is made from renewable resources, that is plant based resources, that is degradable. So it is surely a bioplastics. Yeah, I hope you understood. So this is made from some plant-based renewable resource and it is degradable. So these are all are bioplastics. That's confirmed. So if you go to second quadrant, here it is petroleum based but degradable. So this is also called bioplastic only because it is made up of petroleum byproducts, but it is degradable within a stipulated time. So it is also called bioplastics. And if you go to the fourth quadrant, here it is made from renewable resources but not biodegradable. So all the bioplastics are not mandatory to be degradable. It can be biodegradable also, not biodegradable also, but it's made up of renewable resources. So it is also called biodegradable, bioplastics. Then if you go to the third quadrant, here comes the normal plastics made up of petroleum based and non-biodegradable. This is what we are using nowadays. Polyethylene, polypropylene, polyvinyl chloride, PE, PP and PVC that are all made from petroleum raw material and non-biodegradable. That's what the code says. So all these three quadrant are bioplastic only. So made up of, it can be either having renewable resource as a raw material or petroleum as a raw material, but it should be a degradable one. So any one or either or both can be mentioned as bioplastics. Hope it is clear to you, sir, Vinod sir. Yeah. Yes, thank you. Then we will discuss again. This is called bioplastics. It may be bio-based, biodegradable, or both. Yeah. So here we discuss about bio-based bioplastics. So it cannot be only the raw material is bio-based, but degradability or not, it's not mentioned here. So bio-based means the material or product is at least a part is derived from biomass or a plant-based material. So it can be a natural polymer or a synthetic plastic made up of organic macromolecules. So natural based means any sugarcane bagasse or any type of mushrooms we can use as a raw material. Or synthetic plastics means synthetic plastic that is made up of organic sources. Then it's called a bio-based bioplastics. So it is classified must bio-based material must be of organic origin. This is the definition from ASTM D6866 of bio-based bioplastics code. Yeah. So next we are going to discuss about biodegradable plastics. So here it is not linked with the origin. It is only linked with the chemical structure of degradability. So if it is based on origin of raw material, then it is called bio-based or non-bio-based. So if it is biodegradable, then it is only linked with the chemical structure of degradability. Yeah, that's what the definition. Biodegradable refers to substance that can be broken down by microorganism within a fixed period of time. Yeah. So with bioplastic, biodegradability is directly linked to the chemical structure and not necessarily to the origin of raw material. Hope it's clear. Yes. Here you can say what are the things to avoid and what are the things to prefer. Type of plastics I am talking about, environmental preference spectrum of bioplastics. So PVC is the most non-biodegradable material, so we should avoid that PVC. And some the link to chemical structure means it's polymer chain of plastic. Yeah, it's polymer chain of plastic that we are going to discuss in the upcoming slides. How the structure affects the biodegradability of the plastics. That's why I am going to discuss in the same chart I am going to explain. Yeah, please. Then this color from red to green indicates the environmental preference. Here you can see plastic with highly hazardous should be avoided, and ABS, EVA, you can see the abbreviation here, polycarbonate, polystyrene, polyurethane, these are also we have to avoid. And the polythene, polypropylene are having somewhat good recycling capacity, so we can use that. But most preferable we have to go for bio-based plastic. Bio-based means made up of raw material should be from bio origin, having sustainability growth. Yeah. Then here I am going to discuss about the structure, that is chemical structure. So what we are using now, plastic made up of petroleum byproduct and having non-biodegradability property like polyethylene, polypropylene, polyvinyl chloride. But why it is not degradable? Because all the petroleum products are non-biodegradable. Why? Because the structure, you can Google it, the structure of polyethylene and some of these linkages. how the linkages are linked to the degradability of the material like polyethylene or polypropylene. But here if you see something made up of bioresources having non-degradable properties like biopolyethylene, biopoly asbestos, bio PU, PP. These are also made up of some bio origin materials but having non-biodegradability property like cellulose, acetate, rubbers. This and all having take more time to degrade based on its chain linkages only. But this type of regenerated cellulose will have a more degradable property and may having bio origins. Yes. So these are all things made up of like the range of biodegradable plastic available nowadays like starch based products, water soluble polymers, naturally produced polyesters, you can see the examples here, and renewable resources polyester, synthetic aliphatic polyesters, aliphatic aromatics, hydrobiodegradable polyesters, photobiodegradable plastics, controlled degradation additive master batches. These are all biodegradable plastics available nowadays. Yeah, biodegradable bioplastics. So why to use bioplastic? Why we are converting from normal plastics to bioplastic? Because it reduces and eliminates the greenhouse gas in the production. But compared to disposal, sorry, yeah, compared to disposal point of view, normal plastic will not emit any greenhouse gas. But this type of bioplastic, while disposing in the compost plant, any industrial or domestic compost plant, then it will emit again CH4 and CO2 during the composting process, aerobic or anaerobic composting process. So during production, it eliminates the production of greenhouse gases, and it requires less or no petrochemical raw materials, and it reduces the use of fossil fuels again linked with the petrochemicals only, and relied only on non-renewable relies only on renewable resources. Then the manufacturing process reduces energy consumption by 65 percentage, and it's biodegradable and compostable. That is the major advantage, and it is recycled along the conventional plastics and non-toxic, safe for medical and internal uses. Yeah, this is the main advantage. Now most of the bioplastic finds application in the medical field also because it is non-toxic and with natural additives, so we can use it in medical applications and internal uses. Yes. So what are the problem with the bioplastic? That's also we need to know. Like it's having higher manufacturing cost because to acquire the natural based raw material, it requires a huge money for acquiring. So higher manufacturing cost, and composting should be possible only in industrial composting process, not in the domestic composting like food waste and some of the organic waste. So it need a special condition to compost. So it can be only possible in industrial composting plant. But nowadays research also going on bioplastic to make it compostable in the domestic compost plant also. One of our MTech did project on composting bioplastics and anaerobic degradation of bioplastics in the laboratory scale. So we have achieved 90% of degradation within 30 days of time period. So it is good enough in comparing to the normal plastics. But it can be done along with the domestic composting process. Yeah, that's what our conclusion. Then some can interfere with or damage standard plastic recycling process. So the people may confuse where to keep the bioplastic in biodegradable bin or in the recycling bin, because if we kept it in the recycling bin, then it may end up in the incineration plant. So if we went with the biodegradable bin, that is the green bin, then it will go to the compostable plant. Both it will not work. So there is a confusion, or it may create some it will interfere with the plastic recycling process. So again, it will create some issue in recycling. And then use of plant sugar and starch based have a negative impact on the food prices. So whenever we are going to use again this type of starch for the manufacturing of plastic, then the demand for food will rise. So again, it need to be balanced. The production of raw material for the manufacturing of plastic will increase. Again, it will create a demand in the food crops. Then bioplastic do not do nothing with the consumer's behavior. So if you ban the plastic, then it will have a behavioral change with the consumers or the users. But if you give bioplastic in the market, then everybody will again go for plastic bags, that is biodegradable plastic bags or bioplastic bags. They won't change their behavior, just they will go to the market again with the plastic bags and they will buy. So consumer behavior change is major thing in the waste management scheme. Then not all the biodegradable, not all plastics are biodegradable or recyclable, as I mentioned. The name is having bio, but it is not necessarily need to be biodegradable. So again, it should be create a problem. Then if it is sent to the landfill, as I mentioned, during degradation process, it will release carbon dioxide, and if it is anaerobic condition, it will release again methane, which is a greenhouse gas. So for the production line, it reduces the methane GHG emission, but during the disposal time, it will again releases greenhouse gas. So this environmental balance need to be quantified through some of the impact assessment, and we have to find whether it's really green or not. This green tag should be quantified, and the final problem will be it is not suitable for use in number of products. So most application like water resistance and most of these medical application requires a particular type of plastic which cannot be made from bioplastics. So the suitability of bioplastic in all the type of plastics we need to address. Yeah. These are the problem with the bioplastics. Then various application of bioplastics like films, flushable sanitary products, sheets and non-woven packagings, bottles. Like nowadays, water bottles like normal use and throw water bottles are also coming up in with bioplastics. And then liquid paper boards, planter boxes, and fishing nets. Planter boxes is another major area we have to discuss because all the plants are wrapped with the plastic covers. Now, if it is bioplastic, then it can be buried along with the cover. So it's a good one. Planter boxes, food service cups, cutlery, trays. Because if you order anything in Swiggy or Zomato, you will get plastic packages for all the food cutleries. Sorry, food packages. So in that we can use this type of bioplastics. And nowadays research also going on edible bioplastics. So we can eat the food packaging along with the food, and then it can be used in loose film foams also. So it will eliminate the use of styrofoam kind of foam materials, and we can use bioplastic instead of that. So those are various applications of bioplastics. Advantages are like, as I mentioned, reduces municipality waste, reduces methane during the production, and replaces regular cloths converted back to monomer. Because if we recycle bioplastics, again we can get monomers and biodegradable. Some are biodegradable, that we have to mention. Not everything is biodegradable. Some are biodegradable and requires less energy to manufacture, less petrochemical products, petrochemical raw materials, requires no processing, and can replace fertilizers if used as a compost. Yeah. And then now we are going to discuss about what are the different alternatives we are going to give for plastics. Some thermoplastic starch products are used in food packaging, disposal, eating utensils, loose films, and antistatics and protective packagings. Starch synthetic aliphatics. These are all like thicker materials that can be used in high quality sheets and packaging films. Yeah. And then starch and PBS and PBSA polyesters are used in thermoformed biscuit trays and film products. Starch based, everything is starch based. That means it is having a natural raw material origin. So it is called bioplastics. Then starch PVOH blends, which are water soluble laundry bags, drug control releases carrier, and biomembranes. These are all applications of the different bioplastics. Yeah. Here you can see a comprehensive chart of polyesters, that is PE only, having aliphatic and aromatic. I hope you know about aliphatic and aromatic. Aromatics are having benzene ring in its structure, which will have a smell when it is exposed to the environment. That is called aromatic, having a good smell. Aliphatics are the one which are having a long chain polymer. So polyester can be divided into aliphatic and aromatic. And here we are having different types of biodegradable polyester family, and the color indicates blue color is synthetic, made up of synthetic material but renewable. Pink indicates it is made up of synthetic but non-renewable. Synthetic in the sense synthetic having natural carbon source. Yeah, synthetic which is renewable and synthetic which is non-renewable. Green indicates natural produced renewable resources. This is called exactly the biodegradable bioplastics. Yeah. So you can see the naturally produced renewable sources will be having pH in its name, polyhydroxy. Everything will be polyhydroxy. So that is, polyhydroxy will be from natural based and renewable sources. Only PLA is made up of synthetic and it is renewable. PLA, polylactic acid. Others are synthetic but is non-renewable. These are all from polyester family. Yeah, some of the examples of example for biodegradability. Yeah. Here you can see a plastic bottle which is degrading in the course of time. In sorry, yeah, I'll So this is a plastic water bottle that is bioplastic, made up of bioplastics, which will degrade in the course of time. First it disintegrates and it degrades. This is the process we are going to discuss for the disintegration of bioplastics. Here we are having different types and you can see the degradation period at the different conditions. So PHA, which is natural produced polyester, as we have discussed. PHA, PH family is from natural based but renewable. So that will decompose in 10 weeks in compost plants. So you can see from 2, 6, 10 weeks, and next slide also some of the 8 weeks. So maximum is 8, 12 weeks only. So with from 2 to 12 weeks, this type of bioplastic can degrade in composting or in garden soil or in a form of aerobic or anaerobic conditions, and in a hydrolysis. Hydrolysis means addition of water. So after adding water, it will start degrade. So this type of things we can look into. Like PLA is a renewable resource. As we discussed, the PLA is the only thing having synthetic and renewable resource of polyester, which is having application in drink cups, takeaway food containers, and planter boxes. After using the contents in the cups, we can easily hydrolyze and it will be decomposed in 2 weeks. Yeah. So we are going to discuss about water soluble polymers like polyvinyl alcohol, PVOH. OH will denote alcohol. So polyvinyl alcohol is a readily biodegradable and water soluble polymers. So here you can think of this is a good one, a good product like PVOH having biodegradability property as well as water soluble property. Like it can be made into a film and having good application in the film industries. Like and then PVOH does not biodegrade but simply dissolves in water. Biodegradability in the sense, after dissolving in water, this can be degraded by the microorganism in the treatment plant like STP. If you are a civil engineering background, you may know about activated sludge process in the sewage treatment plant. So there we are using microorganism to degrade the biological content, that is organic content in the wastewater. So if you dissolve this type of PVOH plastic in water, after it reaches STP, it will degrade with the organic matter along with the wastewater. Yeah, that's what this thing. So PVOH does not readily biodegradable, but after dissolves in water, it will be degradable. This is another one, ethylene vinyl alcohol, EVOH. So this is having a water soluble synthetic polymer. So having a synthetic origin, but it is water soluble. Where it is used, like it finds application in the multi-layer packaging as a center layer. Here also, here both sides we are having polyolefin, that is like a film, and in between we are using EVOH as a oxygen barrier layer. This is again a multi-layer film packaging in water bottles or any beverage containers. This type of oxygen barrier is required, and in normal chips packet also you can see we have to maintain the condition of the chips inside the packet. So we need to retard the oxygen entry. Yeah. So we have to retard the oxygen entry into the chips packets. So we need a multi-layer packaging. One to retard the moisture, one to retard the oxygen entry, one to make it for advertisement, one for like storing that nitrogen. Like that, we need a multi-layer packaging system. So here we are using bioplastic as a EVOH as a barrier system, and it is having a high cost in manufacturing. Then photo biodegradable plastics. So in the name itself you can find photo biodegradable. So it won't degrade by the use of microorganism, but uh, it will be degraded by the application of light. So if it passes with the sunlight or any kind of sensitive it is a photosensitive material. So whenever it's exposed to UV or normal light, then it will degrade. That's what the photobiodegradable plastics. So there are thermoplastic synthetic polymers which are incorporated with the light sensitive chemical additives. Not all those materials are made up of normal things. This can be of synthetic origin, but some additive we are adding to make it as a degradable one. So here we are adding photosensitizers like diketones, ferrocene derivatives like amino alkyl ferrocines. These are some of the additives. Like in the manufacturing of plastic, we have discussed more additives to enhance the quality of the plastic, like flexibility, water retardant, and some of the plasticizers we have added as additive. Likewise, here we are adding some additives to enhance its degradable property. Here we are adding photosensitizer as a additive which will effectively degrade when it is exposed to the intense light. So some of the factors like season, geography, dirt or water cover or shading may interfere with the degradation process. Some questions like, sir, can you please say the different microorganisms involved in the degrading plastics? That I have to look into it. Like, you are talking about bioplastics or normal plastics. Normal plastic degradation, some of the research are going on different kind of microorganisms like super bugs for the degradation of plastics. But regarding bioplastic, most of the environmentally available microorganisms will degrade this type of biodegradable bioplastic. But this is the photo biodegradable plastic will degrade only on the exposure, only when exposed to lights. Yes. So it will promote oxidation process, breakdown breakdown into a brittle material. Then microorganism, if it gobbles, it will disintegrate into carbon dioxide, water, and biomass. So the trade name indicates TDPA. If you expand, you can easily understand totally degradable plastic additive that was added when added to polyethylene. Polyethylene is a normal plastic, but if it is added as a 3% only, in 97% of polyethylene plastic, we are adding 3% of TDPA to promote complete degradation. So it is called a pro-degradant concentrate, PDCs, pro-degradant concentrate, like TDPA. If we added, that will degrade, that will enhance the degradability property. So after 4 weeks, 95% of this type of polyethylene plastic will degrade. So here comes the innovation. They are normally whatever the plastic available like polyethylene or polystyrene or polypropylene, we are adding some additives which enhance the complete degradation. Like that additives are called pro-degradant concentrates. Here we are adding totally degradable plastic additive TDPA. That's a trade name. Yeah. These are not strictly biodegradable, but we can say this is a bioerodible because here only the breakdown process happening. It will degrade, it will fragment it into a lower molecular weight fragments. Then it will be gobbled by the microorganism. Then it is degraded into simpler products like carbon dioxide and water and some of the biomass. Yeah. So we can't say this is a strictly biodegradable. This is bioerodible. This kind of pro-degradant concentrate added plastics. Yeah. So this type of pro-degradant concentrates may, find application in the thin plastic shopping bags, disposable diapers, trash cans, trash bags, sorry, landfill covers and food containers. Here if you are seeing landfills and all, daily we need to use cover. Daily cover we will call. Every day after disposing the waste, we need to have a daily cover. Then after the landfill reaches its full capacity, then we are having a final liner with the HDPE liner and soil cover. So the daily cover inside the landfill will remain as it is. But if we are using this type of bioplastic, then the daily cover will also disintegrate along with the waste present in the landfill. So this type of things will find, like if you see disposable diapers, it will remain in the environment for thousands of years, as we discussed in the first week. Diaper will take thousands of years to decompose, like sanitary pads and all having micro beads as a microplastic that will remain in the environment. But we use bioplastics for disposable diapers that will degrade along with the product. Yeah. Some food containers and trash bags. Trash bags we are using daily for the disposal of our day-to-day domestic waste. So like a black carry bag, you know, no? So black carry bag for your dustbins and all we are using. So that trash bag can be made up of bioplastics with the PDCs as a additive. Yeah. So another innovation was made up of like edible food packaging made from milk proteins. So here we can see a video that make edible food packaging material from the milk proteins. And another one company in Italy in Milan, so named Vigia, that manufactures leather from grapes. So leather is another type of leather. We know no? We need to rely on animal skin for the manufacturing of leather, which is also again non-degradable. But if you use they have made innovation in making cruelty free leather from grapes. In 2016 they have founded this organization with they have tested various plant fibers properties, and finally they come up with the wine leather, that is grape skins, fats and seeds. Seeds are used for creating this type of fibers, and they have um, extended their research on using banana fibers and mushrooms, pineapples on and the manufacturing of leathers. Yeah, here we can see another one research on using chicken feathers as a chicken feathers in the manufacturing of plastics. So chicken feathers as a Spanish company is looking to use chicken feathers as a form of plastic to give a traditional waste byproduct a new life. So it is a profitable material. You know, most of the waste is a profitable material, and chicken feathers are having more keratin content, which is required for the plastic manufacturing. And this is a modified starch or plant protein, for example, not only for the manufacturing of plastic, it is having more starch content that can be used for manufacturing of plastics. Yeah. So they have named as a Karma 2022. So they transform unwanted feathers into biodegradable plastics. So feather based material that is injected into a mold. So it's again a manufacturing process called injection molding to shape it. And they have next challenges in scaling up of this type of bioplastics, and it can find application in food packaging from feathers, flame retardant coating, depending on the economic and technical feasibility. So while using this type of bioplastic in the electronic applications and some of the flame retardant coating, it finds challenges. So we can use for food cutleries and some of this packaging material. But coming to electronics and all, we can't use bioplastics like normal plastics. Like if you are seeing your laptop is made up of more plastic items, we can't replace this with the bioplastic. But because it's not having any flame retardant property, it can have a water repellent and strength, but it won't have any flame retardant capacity. So we have to focus our research on this type of area to introduce bioplastic in the manufacturing of electronic items and flame retardant coatings. Yeah. So another research on using mushrooms as a packaging material, because most of the plastic waste is from packaging sector. So we can avoid plastic packaging and we can use this type of innovation in plastic packaging. Like mycelium is a mushroom root, so that can be used in packaging literally, and it will again grow if you dispose. So this design gathers agricultural waste, mixing it with the mycelium in the mold, and then package, and then the packaging quite literally grows. Yeah, this is the manufacturing process or the production process for the mushroom material. So whatever the agricultural waste like corn waste or any kind of sugarcane waste bagasse that we are shredding, grounded, sorted and cleaned before growing, then the root of mushroom, that is called mycelium, the vegetative root structure of mushroom, is added to the mix and binding together to make into a material that is called any packaging material we can make, that is mushroom material we can call. So this mushroom material, this is again the manufacturing process. Growth trays are made up of PET plastics, which is reusable and recyclable. So filled with a mix of substrate like hemp, nutrition flour, and then mycelium as a final additive. Sealed to grow 6 days total, 4 days for a pop part to grow out, and then another 2 days for the outer layer, that is called the velvety layer, to grow. Then final stage is to dry to prevent from future growth. So after growth, we can use as a packaging material. So this packaging material will grow. So we can avoid styrofoam for packaging this type of. So we will use the styrofoam for a shock absorbent, like any electronic product or any glass material, any costly item. If you transfer, we will use this type of thermocol or a foam material as a shock absorbent. But instead of that, we can use mushroom material as a packaging material, and we can avoid a huge volume of plastic waste. Because if you dispose this type of mushroom material in a landfill or anywhere, if you litter, that will grow or that will degrade. Yeah, that's the concept behind using bioplastics. Yeah. And we are going to discuss about alternative materials. Like first, we are going to discuss about the sugar cane, that is sugarcane bagasse. You know, now after many seasons, we can get sugarcane bagasse because it's annual cultivation, so we can get this sugarcane bagasse everywhere. So the bagasse is the name of the residual fiber that remain after squeezing of sugar cans. So it contains 40 to 60 percentage of cellulose, 20 to 30 percentage of hemicellulose, and 20 percentage of lignin. So this cellulose and lignin plays a major role in the manufacturing of plastic from the bagasse, sugarcane bagasse. So bagasse is primarily found in all the countries with a high amount of sugar, for instance, Brazil, Vietnam, China, and Thailand. Yeah. Even though bagasse is so-called byproduct, it is only used as a fuel for the production of their plant itself. Wherever they are using, like if they are making jaggery or any kind of sugar products, they will extract the sugarcane juice and they will use the bagasse as a fuel for the production in their plant itself. But we can use the bagasse in the manufacturing of plastics. So as a byproduct of sugar production, it does not require any additional cultivation area, because if we are going to use mushroom or any kind of corn as a raw material for plastic, we need a separate cultivation area. But if we are using sugarcane bagasse as a raw material for manufacturing of plastic, we do not need any cultivation area, extra cultivation area, because it is a byproduct of sugar production and having no impact on the area of forest. And the paper industry has also started to replace wood fibers with the sugarcane fibers. So these are all some of the product made up of like cutleries, cups and plates that do not pollute environment, are made up of sugarcane, eco-friendly containers. Like it's a company called Papco, a greenware manufacturer that has a entrepreneurship on manufacturing this type of sugarcane based cutleries. So the production process is like the steam boiler and air compressor will be used. First, the sugarcane pulp will be extracted, and then it will be the pulp is used in like pulping process is called whenever we are using, if you see the paper manufacturing industry, the wood will first crushed and mixed with water, then pulping process will be there. Pulping means digestion will eliminate this cellulose content. So whenever we are heating along with the water, that will be softened and made into a kind of a mixture that is called a pulping process, hydraulic pulping. Then pulp is mixed in the mixer, then forming machine, it will be sent to the forming machine. After extracted the excess moisture content, it will be entered into the forming machine, where the steam boiler and the air compressor will be applied. Then we can shape the material and edge cutting. Because it is from a waste, we have to sterilize the waste before using in any food or human application. So we have to sterilize with UV sterilization, then the final product can be dispatched. So this is the steps of bagasse production. The first one is pulping. Pulping is like soaping the pulp paper board and put it into the hydraulic pulper. Add water and add oil additives. Then forming. Forming is like this whatever the pulp that is made, that is back flushing through black flushing power supply, vacuum dewatering and forming with advanced technology to eliminate holes and uneven thickness. So here the forming machine will be there. Forming is like a what we call like this pulp is sent to through the mold, and the mold will be added with all this type of air compressor to eliminate uneven thickness. So it can be spread over across all the edges of the mold. So that's called the forming process. Then shaping and drying, whatever the excess edges we can shape and dry. 70% of energy will be saved here. Steam is used for heat drying. It can be used for food packaging and enhanced resource utilization. and the production rate can be up to 99%. Then finally sterilization to make sure the production meets hygiene requirement. Finally packaging and stored. Yeah. So what are the use application like it's a sorry uses is like very stable and sturdy and not very flexible. Good thermal property. It can range from -25 to 220 degree. It will withstand and water repellent and grease proof because bagasse is a grease proof material. Also suitable for hot and very oil greasy dishes. So we can use as a food packaging material and then completely biodegradable and compostable. That's all the special characteristics of bagasse products. So here you can see some of the Vegas cutleries and seaweed based water pouch. So to eliminate water bottles made up of plastic, nowadays researchers are going on seaweed based water pouch. So that is edible again. So if you gobble this water along with the packaged seaweed, then you can assimilate both water as well as the packaging material. So this is one kind of innovation. So here not only biodegradable, it's also edible. So here drinking water within a edible membrane. You can see a membrane having water inside, in water packed inside. So edible membrane made from the natural seaweed extract which is biodegradable in just 4 to 6 weeks if you throw out. But if you eat, it will be again digested. Yeah. So what is the production method? First, it's a simple method of production of this type of edible products like sodium alginate we have to dissolve in water and then calcium lactate will be dissolved in a separate bowl in water and then transfer the sodium alginate with the calcium lactate bath, stir the solution, transfer water balls to water bowl. So easy step for the production of edible membranes. Yeah. Then this kind of papers we can say this is a paper made up of natural material which avoid plastic stickers in the any kind of products or you can say this is a thick wooden like not a wooden a cardboard kind of thing made up of papers. So first ever shower safe paper bottles cause a splash. So whatever the shampoo bottles we are using that will be made up of plastics. But if you use this kind of eco-friendly materials for the manufacturing of containers, then it which having a water repellent property, then we can use this for bathroom whatever things we are using like Eco Beauty ranges seed phytonutrients that having 93 to 100% natural ingredients, cruelty free, paraben free, etc. This kind of L'Oreal have already introduced this kind of paper packaging materials. So outer cord is recycled, recyclable, compostable, glue free. Again, this is another important thing. So glue will have less biodegradability. So this is having a glue free and water resistance property. But the inner liner is made up of again recyclable plastic only, which is having so this type of multi-layer packaging will reduce 60 percentage of material in the manufacturing than the regular plastic bottles. Yeah. So here you can see 60% is a huge number. 1 ton of plastic bottle means only 40 tons of plastic, then 60% is from biodegradable material. So another one paper bottle from a company called Pat Rayons. Wine, pet food, protein powders, and laundry detergents to a molded pulp outer shell from the recycled corrugated and old newspapers. So inner film everywhere inner film will be made up of polyethylene or polystyrene material, but the outer layer we can cover with this type of renewable resources. And inner layer should be recyclable. That is again important, not through PVC or any kind of thing. It should be recyclable plastic like polyethylene and reduces plastic usage dramatically, ecologic and one truckload of packaging material equals to 9 truckloads of rigid plastic containers. This is again a huge number, you can say. So very thin extrusion blow molded liner that is fully recyclable, 80% of post consumable HDPE, 60% less plastic, eliminate the use of glue, interlocking patterns also we can now create. Instead of a glue system, we can make the biodegradable plastic along with the interlocking system that will directly lock it into. Another one innovation in stone paper and plastic. Stone paper is a kind of thing which can be manufactured from 80% of limestone and 20% of recycled polyethylene plastics. So if you blend this two, it is called stone paper, which results in 100% ecological product. So which find application in the posters, flyers, bags and all. Is mostly used in the hang labeled and pot covers by growers. So it is suitable for polypropylene. Substitutes for polypropylene because it is the water and UV and tear resistant and having a thickness between 100 and 400 microns. Since we are using limestone, we are calling it as a stone paper. Yeah. So in environmental impact assessment, we have different strategies. You know, cradle. Cradle is what we call like the one with baby will be sleeping. That is called cradle. That is from the birth to grave. Grave is with from the death. So whatever the material we are analyzing from its birth, from the raw material extraction to the death, that is called a disposal. We are analyzing the impact of a material, then it is called a cradle to grave assessment. Then if you are finding the I mean analyzing the environmental impact from its production point of view alone, then we will call it as cradle to gate. Gate is in the sense from the manufacturing process unit. So whenever the raw material is extracted and during the manufacturing process some of the additives were added and energy was given, water is supplied, then it may be made into a final product and it is reaching the gate of the production line. Then it is called a cradle to gate. Uh, Before consumers application, then it is called cradle to gate. Nowadays researchers are going on recycling product, that is called circular economy products. Then we have to think about cradle to cradle principle, not to the grave, not to the disposal point. Wherever the raw material is extracted, again the same material, disposal material can be used as a raw material for the production line. Then it is called the cradle to cradle principle. This type of stone paper will be a cradle to cradle principle and does not require any water, cellulose or acid bleaching, and no cellulose means no cutting of trees. So again it is a reduction in the raw material and environmental impact. And the CO2 emission are about 63% lower in the production of stone paper than in the production of cellulose paper. Yeah. So these are different products of stone paper. And another one is like from the palm leaf. So palm leaf will be made up of you don't know normal leaf only. After drying, we can press it and we can use as a food packaging material. So it is again a renewable resources. It's by a company called Biopack, which is a packaging specialist. After they are making this type of food packaging containers from the palm leaf. So which is easily compostable in 12 weeks and reduces the impact on the environment, which is again an alternative to plastics. So nowadays, all the weddings or any event if you go, they will serve with this type of palm leaves containers. Yeah. Another one natural alternative is corn starch or sorghum you can call, which is as a loose fill. So maize, better known as corn, is an annual summer plant which will perform photosynthesis and it will accumulate starch in it, and it is not required non-required sugar is stored in the form of starch. So we can use as a raw material for the production of bioplastics. So a company called EcoFlu, they manufacture EcoFlu loose fill is made up of corn starch, which is biodegradable, adder free, and made be best of all static. Yeah. So the production step is again easy. Cornstarch is fermented into lactic acid by the aid of lactobacilli, and the lactic acid is then transformed into a long chain polymer. Whatever the plastic is a long chain polymer only. So forms a long chain carbon polymer called polylactic acid (PAA) by polymerization process. Then finally the polylactic acid (PLA) is molded into small plastic pellets. As I said, PLA is synthetic but renewable. Yeah, which is molded into plastic pellet and produced many different objects like bioplastic foils, PLA cups and bowls. Then green boxes, PLA cups and bowls are ready for use. Yeah. So the application is like it's made from renewable resources and reduces the use of petroleum products and not intended for human consumption. That is again a major source. Like corn used for the starch production is not intended for human consumption, and only 0.05% of the global starch production is used in the manufacturing of bioplastic. So it won't impact the demand of corn production, and therefore the cultivation has no impact on the food supply of human and animal. And it is having a special characteristics of high stability, free from BPA, and 100% herbal raw material, biodegradable as per the European National Code, and thermoplasticity. Yeah. So another one is edible six-pack drinks. Whenever you are buying any cool drinks or beverages, it will come in six-pack ring. Whatever like beverages will be packed in this type of six-package ring in a plastic ring. But now if you replace the six-pack ring with bioplastic, which is even if it's edible, then it is easy to dispose. Whenever you litter, that we can be edible, so no problem to the ecosystem. Yeah. So like saltwater breweries manufacture the edible six-pack hold, which is made up of beer byproduct, barley and wheat remnants. Whatever the byproduct leftovers from the beer production, whatever the bagasse left, that we are using for manufacturing of this manufacturing of what six-pack rings. That if it end up in the ocean, then it will safely disintegrate and more expensive to produce. That is again cost expensive. Whatever the bioplastic we are using, that is very expensive to produce, and the customer will be willing to buy or not. That is the biggest challenge. And once it end up in the ocean, in a matter of hours, it start breaking down. So no problem with any entanglement of aquatic animals. So here there is not no problem for this turtle whenever we are disposing this type of six-pack rings, biodegradable six-pack rings. Yeah. And then silver board, which is a metallized paper. Instead of plastic packaging, we can use a metallized paper. This type of metallized paper is made up of metallic layer vacuum deposits on over the plastics. Oh, sorry, over the paper, yeah, which gives the metallic finish on packaging and remains compostable. Used widely in labels. Wherever the label we are using through plastic stickers, that can be replaced with the metallized plastics. So it's having excellent printability. It works on all printing techniques and facilitate cutting, labeling, and recycling. Ensure ease of handling, high productivity, and low cost, higher biodegradability on the application. So here you can see all these stickers and packagings are made up of metallized papers. Yeah. Then wood pulp cellophane, which is Natural Flux is a sustainable younger brother of cellophane, which is made up of FCC certified wood pulp. You know, no, normal wood pulps, we can use that as a raw material for the manufacturing of plastics, which is uncoated and perfect for chocolate and confectionaries because it's food safe. So we can use for any food items and confectionaries. This type of cellophane, which is a bioplastic made up from wood pulp. Then scientists discovered prawn shell plastic bags. That is a grocery bags made up of shrimp shell. You know, shrimp. We can make grocery bags out of the shrimp cells. So in Nottingham, Nile University, they have synthesized a biopolymer nanocomposite material, which is biodegradable plastic, dissolving chitosan flakes. You know, chitosan is a material available in the shrimp shell. So nowadays, more application for this chitosan as absorbent in water treatment and everywhere we are using chitosan, which is available in the shrimp cell. So first dissolving this chitosan flakes uh, derived from the shrimp cells in the traditional polymer processing techniques, we can obtain plastic grocery bags, bioplastic grocery bags, which is having antimicrobial, antibacterial, and biocompatible properties, and lower carbon emission, reduce wastage accumulating. Yeah, you can see these are the packaging material made up of shrimp cells. Yeah. But again, while manufacturing bioplastic, we have to think about how to dispose the bioplastics because that's what the problem we faced during plastic manufacturing. Plastics having good application, but how to dispose the plastic, manage the plastic waste is the major problem. So here also we have to discuss about the method of disposable of bioplastic after use. So many things we can do, like we can easily litter wherever. If you throw, even in 2 weeks it will degrade, so no problem. Only some aesthetic problem, but it will degrade. If you throw it in landfill along with the biodegradable, it will degrade. In salt water, you can dispose. In thermal recycling, you can go because it's having a good calorific value. In feedstock recycling, if you eat also some edible bioplastics, it will digest in the human body and it will break down in the ground. Biogas plant we can use in the anaerobic digester and in incineration plant, and then in industrial and domestic composting also we can biodegrade this type of plastics, bioplastics. Yeah. So major potential disposable options, the same what we have discussed already. Uh, Emerging applications like coated papers, agricultural mulch films. In if you see, if you go to any strawberry cultivation farmlands, you can see some more plastic will be used in the mulching process during agricultural process. Um, Hello, am I audible now? I think I lost the connection. Am I audible? Hello, hello, am I audible? Hello, am I audible?
Yes, yes.
Sorry,
Yes.
sorry, I lost my connection, I guess. Sorry. Can I continue? Hope my
Please
screen is, yeah.
continue.
I think I left in this slide, yes. Hope my screen is visible. I, you all are in the slide, right? Disposable methods for bioplastics. continue with the emerging applications. Yeah. Sorry for the technical glitch. I'll continue with the emerging applications area of bioplastics. My voice is clear, I guess. Okay. Some of the coated papers and agricultural mulch films. If you see strawberry mulching, strawberry will use some of the plastic mulching techniques and shopping bags, food waste films and bags. That are the emerging application area of this bioplastics and consumer packaging material, landfill cover, which requires biodegradable material, bag bags, and then fishing lines and nets. If, because we've seen most of these plastics in the ocean or from the fishing nets. So we can use this bioplastic as a fishing line and nets, and which is having good strength property. And then silage wraps, body bags, and coffin liners. Coffin liners, if it is degradable, then it will degrade along with the remains. Then nappy bagging sheets, various sanitary products, and cling wraps. We can use the bioplastics. Then improving the biodegradability. These are the future potential modifications. Easy degradable or faster degradation or the potential modifications we need. Better barrier properties. Addition of SiO2. SiO2 is an inert material. So if it degrades, that is nothing a problem. Carbon fiber and other metals. Increasing thermal conductivity and specialized enzymes can enhance the production and cost effective manufacturing, because this bioplastic production will require higher production cost, so cost effective manufacturing, same like petrochemical prices, so which is the need of the hour in bioplastic manufacturing and the usage. But some of the adverse environmental risks are also there in the bioplastic, because whatever the bioplastic we are littering into the environment will add BOD concentration, that is biochemical oxygen demand concentration in the wastewater bodies. Whatever because plastic, if you discard in the water, it won't degrade and it won't impart any organic content in the water. But if you discard biodegradable bioplastic in the waterways, then it will add organic content in the water, same like food waste if we discard in the wastewater, and whatever the wastewater having by BOD, this plastic will again increase the BOD content of the wastewater, which we need to address, and we need to design the treatment plant accordingly. And the migration of plastic degradation byproduct. Some of the bioplastic may not be fully biodegradable, and some may disintegrate. And the byproduct like residual pigments, most of the additives are non-biodegradable. Only plastics is biodegradable, but additives like pigments, catalyst, which isocyanate, which are all toxic, and it will migrate when it degrades. And then trauma and death of marine species resulting from only partially or slow degradation by death. But comparative to normal plastic, it is good. But even though if some of the plastic when eaten by the aquatic organism, that will cause death of the marine species and possibly increasing the incidence of littering. When I say you can discard the plastic waste anywhere, it will degrade. Then everybody will not use dustbins. They will simply litter the plastic, thinking that it will degrade. So it will increase the incident of littering. And use of this compost in the soil will reduce the crop production, and unacceptable high organic and metal contaminant will be coming to the agricultural fields. And then biodegradable plastics are residues, additives, and modifiers such as coupling agents, plasticizers, fillers, catalysts will remain in the environment. It won't degrade. So these are all the problems, health, environmental risks associated with the biodegradable plastics. So as I mentioned in the first slide, we have to quantify whether these bioplastics are really green or not. For that, we have to use the LCA approach, which is life cycle analysis process. Life cycle analysis is whatever the during the life of the product, we can assess life cycle of the product, we can assess its environmental impact. That is called the life cycle assessment during its manufacturing and during its usage phase. Both phases we can assess the impact of the product to the environment. Yeah, that's what we can assess through LCA method. LCA is life cycle analysis technique. Yeah, in this we have to first fix the goal and the scope. That's the first step, goal and the scope definition, where we are going to end, from the cradle to gate or from the cradle to gate, grave or cradle to again to the cradle. This scope we have to fix first. Then inventory analysis. What are the data we required? If we use from cradle to gate, then how to extract the raw material? How to what are the energy we are going to give? What are the water it requires? Energy demand, water demand, and then like environmental footprint, what are the emissions? This all data we need to analyze. That is called inventory analysis, that is data acquisition. Then finally the impact assessment. With all the data within the scope, we can analyze the impact of the product manufacturing, that is from cradle to gate. What are the impact of the this plastic manufacturing or any product manufacturing? That is called impact assessment. And during all the steps we can interpret, that is called the interpretation. So this whole steps will be included in LCA approach. If you want to compare two product, like one pencil from one company and another pencil from another company, and that they are telling us that pencil we can take as the plastic pen. One is called made up of plastic, another one is made up of like I am having, can I switch on my video? Yeah, if you see how my video is visible. So this is one plastic pen, that is flyer pen I am having, made up of plastic, and inside also we are having plastic refill. And this is one of the pen I got from Center for Environmental Studies, and this is having plastic pen inside refill, but the cover is made up of paper. What are the waste they are generating in the institute, that they are making the same pulping process they are using and manufacturing as the paper wrap for this pen. So this is one green alternative we can say. If I want to compare this two product, it is really a green and it will really having less impact to the environment or not, that can be analyzed through LCA process. So for the manufacturing of this two material, I have to analyze all the data and all the emissions for both of this product, because it need only synthetic material, but it need whenever it is made up of waste, that is fine, but whenever it requires any tree cutting, it will again having impact on the environment for the acquisition of raw material. So we have to assess all the parts from the cradle scratch to end of its life. When we dispose this, what will happen to the environment, what it will release to the environment, that and all we need to assess. So while comparing any two process, we have to do environmental impact assessment or life cycle assessment. Environmental impact assessment is a global process, but LCA is a local thing. For a for any uh, for any product we can do LCA. Yeah. So in goal and scope definition, we can first do unit selection and then inventory analysis. What are the material in and what are the material out? Not only material, energy in and out, material in and out. What are the data we need to acquire? Then finally, impact assessment. What is happening to the environment? That's what we are going to do in the LCA. Elementary flow we need to have. Elementary flow means in the production line, what are the things getting in and what are the things getting out? That is called the elementary flow. Inputs like in any manufacturing process we have, these are all some of the examples like iron ore, crude oil, water, wood, and solar energy, land use. If it is a bigger industry, then it having a land use also, that also we need to assess. So those are all input, but output as a emissions of carbon dioxide, SO2, particulate matter. Some examples like volatile organic carbon, and then phosphates, nitrates, pesticides, metals will be emitted to the environment. So more input and output we need to taken into consideration. Yeah, I'll continue. So this is called the inventory analysis. Very hard to interpret by manually. So we have lots of tools like OpenLCA software is available for free. Pro software is there, which is paid software, and lot of more software and tools are available for LCA analysis. Yeah. Then neglecting some process we can neglect, which contribute less than 0.1 percentage of environmental. Not required to analyze all the processes involved. We can neglect some of the insignificant processes. Yeah. So these are all database. already some database we are having, like Echo Invent is a website. You can go and search for all the database related to impact assessment, like EMPA, which is an which is a body in US that is having plastic, paper, and basic chemical inventory. If you use 1 kg of plastic, how much emission? If you use 1 milligram of paper and board, how much emission milligram of CO2 will be emitted? How many milligram of PM will be emitted? That all database will be there. Just we have to input and we have to get the output. That's all database are already available. So for manufacturing of bioplastic, how much starch products I am using, how much corn I am using, how much mushroom I am giving as input, how much water I am using. For that, how much emission will come, we can get from the database, and finally, as a one value, we can get the result. So this is the elementary flow. We can analyze the impact, such as we can categorize the impact and damages in four categories. One is human health, one is ecosystem quality, one is climate change, another one is resources damage. First one is to the human health, like human toxicity, respiratory effect, ionizing radiation that will cause skin cancers and all. Then ozone layer depletion, photochemical oxidation. Again, it will cause some irritations. So this five will be categorized under human health. Some to the ecosystem, like aquatic ecosystem, terrestrial acidification and eutrophication, land occupation, aquatic acidification. These are all ecosystem quality. And then for global warming, like climate change, and then resources like renewable resources depletion, mineral extraction. These are all different results will come. So result will be in this form, and we can categorize in this four uh, broad categories. Yeah. So LCA result will be this much radiation, this much smog, this much carcinogens will be emitted, this much climate impact. So finally, categorized weight. We can give some weight. I mean, weight in the sense one factor for this, two times of weightage for this, three weightage for this. Like, and we can give some weightage and we can interpret the result. First, we have to give the inventory, that is the data, and midpoint will give some result, and finally endpoint results will be there. So this is called the midpoint analysis. Yeah. So weighing and interpretation. So finally the result will be in a single score. So if you are a civil engineer or environmental engineer, you may know water quality index. Finally WQI will give you a one value that you can use to get the quality of the water, good, very good, or moderate, or severe pollution. Like that, with a single value of water quality index, you can assess the quality of the water. Like if like in air pollution also, we have AQI. In daily newspaper, you can see Delhi AQI, or in your local region AQI, air quality index. With one number, with all the pollutant included, they will make into a one number. That number will be compared with the standard chart. Very good or severe, moderate or very severe. We should not go out. Like that, air pollution can be compared with one value, that is AQI value. Like that, life cycle assessment will give you final single score that can be compared with the standard values. So this will be useful for the designers, product managers, and the EMS specialist. So whenever we are going to design a bioplastic, we have to do a LCA life cycle analysis for the product. So overall, as a conclusion, bioplastics will be expensive than regular plastics, but having a variety of uses and application benefits over the normal plastics. It will cut down the municipal waste, reduces the greenhouse gas emission. It can be used as a fuel, environment friendly, and as a developing technology, these benefits will improve and the cost will be competitively competitive in the market. So we need a technology to reduce the cost of manufacturing of bioplastic. So to quantify the environmental benefits, tools like LCA can be used to quantify the impact. Sorry, impact, and both we can analyze whatever the impact and whatever the benefits through LCA. Yeah, this is the conclusion of this week's lecture. Now, I think you are clear about what is bioplastic and what are the green alternatives for the plastics. If you have any doubts, please post in the chat box, or you can also unmute and ask. Else, I will go to the assignment solving session. If you have no doubts, I will move on to the assignment solving session. Yeah. So here comes the first question. Please put your answers in the chat box for the questions. Plastics are referred green if they exhibit what properties? Source renewability, biodegradability after the end of the life, environmentally friendly processing, all the above. Yes, it's correct. So if it need to be green, it should be from a renewable source. It can be biodegradable after the end of life, or processing should be environment friendly. So then it is called a green. Yeah, all the above is correct. So here comes the green definition of green plastics. Moving on to the second question. A significant characteristics of bioplastic product, bio-based product is bio-based. Bio-based means the product is non-biodegradable. The product is 100% derived from synthetic polymer. The raw material is at least partly derived from biomass, that is from plant base. All the above. For bio-based bioplastic, not for normal bioplastic. So we have discussed what is bio-based. Sorry, again I lost my network. The answer is C. Yeah, that's correct. Hope I am audible now. Uh, can anyone please text? Am I audible?
Yeah, it's audible.
Yeah, thank you. Sorry for this. Uh, yeah. So the answer is C. The raw material is at least partly derived from biomass. So bio-based means that is denoting only to the raw material. Degradability means it's not based on raw material. It's based on chemical linkage of degradability or not. So bio-based bioplastic means raw material is least partly derived from biomass. Yeah, that's correct. This is called bio-based. Where it is. To be classified as bio-based material, it must be organic origin and contains a certain percentage of new carbon derived from biological sources, at least partly derived from biomass of plants. Yeah. Third question: which of the following is an advantages of bioplastic? Bioplastic do nothing to change consumer behavior regarding their use of plastic product. They can interfere with or damage the standard plastic recycling process, reducing or eliminates greenhouse gas during its production. All the above. This is called advantages of bioplastic. Yes, correct. Hmm. Yeah. So coming to the advantages, it reduces and eliminates GHG during its production, but during its disposal, normal plastic won't emit any greenhouse gas, but bioplastic will emit greenhouse gas. But during production, it reduces or eliminates greenhouse gas. That's the concept. This is the uses of bioplastic. I mean, why use bioplastic? Reduces or eliminates GHG in its production. Yeah. Fourth question: compostable plastic has to meet which of the following characteristics? Compostable plastic, as per the code, the definition is the rate of degradation should be similar to other organic waste. 50% conversion to CO2, water, and biomass through the action of microorganisms. Mineralization in a period of fewer than 500 days. None of the above. To be a compostable plastic, what are the requirements? Uh-huh. Sandamilan sir, can you please check your answer? One of the option is correct, I guess. Not none of the above. Not B. Not B. It's actually 90% conversion. It's not B. It's not B. Can I go to the slide? It's not C also. For criteria for compostable plastic, how it will be 500 days. Compostable plastic means it should be less than 180 days. So first option is correct. Yeah. Three conditions to meet the compostable plastic. Yeah, I will go to the answer. Yeah. So for mineralization, fragmentation and impact on the environment should be lesser. So in mineralization, we have three criteria. One is 90% conversion to CO2, water and biomass. But 90% conversion should take place within 180 days. And the rate should be similar to other organic waste like food waste, leaves, grass. So the option A is correct. Yeah. Okay, fifth question. Which synthetic polymer are incorporated with the light sensitive chemical additive to enhance the biodegradability in specific environment? Biodegradability not only means like microorganism, maybe due to some other factors, environmental factors. So, which is light sensitive chemical additives will be added to oxidegradable plastics, photodegradable plastics, starch based plastic, water soluble polymers. Yeah. Light sensitive means it's photo biodegradable plastics. That's correct. So these are the one having incorporated with light sensitive chemical additives or copolymers for the purpose of weakening the bond of the polymer in the presence of ultraviolet radiation. Whenever the sunlight which is having UV rays which falls on the polymer will weaken the bonds. That is called light sensitive plastics. That is photo biodegradable plastics. So moving on to sixth question, the plastic additive which promotes oxidation process that breaks the plastic down into brittle, low molecular weight fragments are ferrocene concentrate, diketone concentrate, carbonyl concentrate, prodegrant concentrate. Yeah, I understand these names are critical, but it's easy. Which promotes oxidation process and break down the material into brittle. Prodegrant concentrate. Correct. We have discussed about PDC, prodegrant concentrates. Like, can you give some examples of prodegrant concentrates? TDPA, which is a trade name, totally degradable plastic additive, which promotes oxidation process that breaks the plastic into brittle, low molecular weight fragments. Yeah, that's correct. Okay. So can I move to the next question? So this DDPA added to polythene as a smaller quantity as a 3% will enhance complete degradation, promote complete degradation of 95% within 4 weeks. So bacteria friendly fragments. These are all innovations. Yeah. So seventh question is like polyvinyl alcohol PVOH is readily biodegradable polymer. PVOH is a water soluble polymer. So both statements are individually true and statement 2 is correct explanation of 1. Both statements are individually true. Statement 1 is 2 is not the correct statement of 1. Statement 1 is true, 2 is false and vice versa. So PBOH we have discussed. No? PBOH polyvinyl alcohol having two properties. Um, A option A. Actually, initially I thought A is correct, but answer is not A. It's not A. Can I move to the answer? It's B. Yeah, it's B. So PBOH is readily biodegradable. It's water soluble polymer, but both are not related. Yeah. So our answer is like both statements are individually true, but statement 2 is not the correct explanation of A. The answer. It's not D. Both are correct. It's biodegradable, readily biodegradable only. When it is added to water. So if you see the final point, it is contradict. PBOH does not biodegrade but simply dissolve in water, but it can be biodegraded by the activated sludge treatment. So we can say PBOH is a biodegradable water soluble plastic polymer. So it's biodegradable only. So eighth question, which of the following is a synthetic and renewable biodegradable polyester? So we have discussed the polyester plastic polymer family. In that, one is synthetic with renewable biodegradable property. PHA, PHB, PBAT, PLA. Um, Not A, because all pH families are separate. In polyester itself, pH is separate, polyhydroxy is separate. So two options is having pH, so that won't be the option. So option C or D. Yeah, option C is correct actually. PLA. So if you see in this polyester family chart, as I discussed, PLA is the only thing which is synthetic and renewable. And pH family having pH which is of natural origin and renewable. Natural is actually renewable only, and PLA is the only one synthetic with renewable property, and other pink will be PB and PC having things are all non-renewable synthetic properties. Sorry, synthetic and non-renewable characteristics. Yeah. Moving on to ninth question. Bagasse contains dash percentage of lignin content. 25 to 30, 40 to 60, 20 does not present in bagasse. We have discussed that bagasse is a byproduct of sugarcane, which is having cellulose, lignin, and protein content. Yes, 20 is correct. Sorry, not protein, cellulose, hemicellulose, and lignin. So 40 to 60% as cellulose, 20 to 30% as hemicellulose, and 20% as lignin. So lignin is the one which determines the biodegradable property. So do you know which is more easily degradable, A4 sheet or newspaper? A4 sheet or newspaper? And why? Which is readily degradable? Not readily, degradable, biodegradable. So I will say A4 sheet is easily degradable compared to newspaper sheets, because A4 sheets are processed sheets which will have a chlorine bleaching processing technique. So that will bleach all the lignin content out of the because papers are made up of wood pulp. So first they will cut the plants, they extract the pulp from the wood, and from the pulp they will make sheet, and the sheet will be bleached with chlorine to remove all the lignin content, and then that will give you the white color. After bleaching we will get the white color after removal of lignin content. So this lignin removed paper sheets are readily degradable, but whatever the newspaper available that is having lignin content in its wood as a raw material, so it is not readily biodegradable. So if you dispose this type of papers in landfill, after after 100 200 years also you can open the landfill and you can read the news in the newspaper. So that much degradable, I mean non-biodegradable capacity for the lignin. So it's having only 20% lignin content. So it's easily degradable, I can say, comparatively. Yeah. Then question 10. Product made up of bagasse are an assimilation of which of the characteristics? Bagasse is bio-based material, water soluble. Water soluble, biodegradable. Bio-based material, biodegradable, water soluble. Bio-based material, biodegradable. The answer is uh, So two things we can say. One is which base, bio-based or synthetic base. I mean petroleum base. It's bio-based. That is final. So option A, C, D. Biodegradable. As I mentioned, bagasse is having only 20% liquid content, so it's easily biodegradable. That is also correct. But it is, but it is water soluble or not? It's not water soluble because bagasse, sugarcane bagasse is not water soluble. So bio-based material, biodegradable material. That's correct. D is correct. So 11th question. Select the correct statement related to bioplastics. Bioplastics. All biodegradable plastics are compostable. Is it correct? All biodegradable plastics are not always compostable. Compostable plastics are always biodegradable. You can choose more than one also. You can choose more. It's a multiple option question. So you can look into option B also. Yeah, B and C. That's correct. Yes. So option A is wrong. Biodegradability means it may be compostable, it may be any other form of degradation, but it's not only through composting. It may be photo degradation also. So first question is wrong. C is actually exactly correct. Compostable plastic are always biodegradable. That's correct because bioplastics are compostable. Is one subset of biodegradable. All biodegradable plastics are not always compostable. That is also correct. So B and C are correct. This is what we have discussed. The difference between biodegradability and compostability. So this is a true or false question. Bioplastic refers solely to biodegradable or compostable plastic made from natural or synthetic material. True or false? Solely to biodegradable or compostable plastic made from natural or synthetic material. Here more options are there. True or false? What else we need for bioplastic? Can be biodegradable or it can be compostable, can be of natural origin or synthetic origin. What else we need? Or is it fine for the bioplastic definition? So option A, that's correct. True. So the term bioplastic does not solely refers to biodegradable or compostable made from natural material. Can be either bioplastic or biodegradable or both. Not only to biodegradable or compostable, but also from synthetic. That's what they have mentioned. Natural or synthetic. So it's true. Okay. Select all different application area for bioplastic. Consumer
So
packaging
will you
material.
again show that question?
Yeah,
Will you again show that question?
yeah.
Previous question.
Actually, in the definition, synthetic is missing. Hope you will understand. False. No, actually, here it's given natural or synthetic. I will go to the definition. Here you can see non refers only to biodegradable or compostable from natural material. Can be from second definition. If you can see, name also applied to petroleum based that are degradable, plant based that are not degradable, plastic that contains both petroleum based and plant based. That was the synthetic means. That may be biodegradable or not. So here they are having both options or okay. Made from it's given. Okay. This is again tricky. Plastic made from natural or synthetic, which is a biodegradable.
The word solely means, I think the statement is false.
Yeah, we can take this as false. Yes. No, solely in the sense biodegradable or compostable. Okay. It may be non-biodegradable also. Yes. So it's false. You can take this as false. I'll change. This is false. Because if the second definition is given, it's easy to find. Biodegradable or compost, not solely to biodegradable or compostable from natural material, but also from non-biodegradable also. A plant-based, that may be, it may not necessarily biodegradable. That is also correct. Yeah, it's false. Thank you. 13th. Is it clear? Can I move to 13th? Yeah. So different application area of bioplastic: consumer packaging material, electric insulation, agricultural mulch, film, battery electrodes. So different application, multiple option question. A and C. That's correct. What about B and D? Electric insulation, battery electrodes. Application of bioplastics. Yeah. So we can't use for electrical insulation because of flame retardant capacity. Because of non-availability of flame retardant property, we can only use for consumer packaging material and the agricultural mulch films and some more. Yeah. A and C are correct. Here are some of the application areas that we have discussed. Okay, so 14th question. Baggage products that I have mentioned, sugarcane baggage product have suitable thermal property, sustaining temperature from, it will withstand from -25 to 220 degrees Celsius. True or false? Yeah, it's true. As per the characteristics of bagasse products, has having a good thermal property, suitable for the temperature from -25 to 220 degrees Celsius. Then pro-degradant concentrate product containing PDCs are biodegradable. True or false? Pro-degradant concentrates. This is again a tricky question. Pro-degradant. But answer is false actually. Not strictly biodegradable, it's bioerodible. That's what we have discussed. Actually, we are adding TDPA to the polyethylene, which will promote degradation 95% in 4 weeks. But as you see the definition, it will promote the oxidation process, which will break down the plastic material into low molecular weight fragments. Then finally, it's taken by the microorganism, then only it will be disintegrated. So PDCs will enhance the breakdown property. I mean brittle property, not the biodegradation property. So we can take it as a not strictly biodegradable, but it's bioerodible. So that's why this option is false. PDCs are not readily biodegradable. It's a bioerodible
So
material.
what is the exact meaning of bioerodible means?
Erode in the sense, not degradation, disintegration, reduction in the size, like a microplastic that won't degrade.
Okay.
I hope you go. If I take a sheet of plastic, that will disintegrate into 1 mm cross 1 mm uh, like particles. Then finally it will be degraded because it's taken by the microorganism and it is having a lower molecular weight fragments. But this will be added as an additive. PDCs will enhance the brittle property, not the degradation property. Yeah, that's called eroding in the sense, tire will erode. Tire will be rubber tire will erode into small particles. It won't disintegrate. Degrade. It will disintegrate. That is the erosion property. Yeah, building walls will erode. It will be eroded into finer particles, not disintegrate. So again, most of the question will be repeated. I'll skip some of the repeated questions. Plastic will be referred to green if it exhibit all the three properties. Yeah. So major characteristics of bioplastics: the raw material should have at least they partly derived from biomass. So advantages of bioplastics: it will reduce or eliminate GHG during its production. Compostable plastic, and we have discussed the same rate of degradation. Synthetic polymers are incorporated in light sensitive chemical additives, enhances biodegradable property, that is photo or biodegradable. The plastic additives which promote oxidation process and breakdown, that is pro-degrade concentrate. This you can answer. The vegetative root that is used as an ingredient of a mushroom based plastic replacement material is called. So two things will be added. One is agricultural waste plus some mushroom based material, that is vegetative root called mycelium. Yeah, that's the manufacturing process. Agricultural waste plus mycelium we mix and mold, it will grow. The mold will actually grow. So after some growth, to cut drying to retard the growth, and we can use as a packaging material. So which are the following polyester is synthetic and renewable? So only one PLA. Uh, which one of the following? You can answer this question. Which one of the following is one of the method of disposal of bioplastics? Landfilling, feedstock recycling, composting, all the above. For bioplastics. Yeah, you can have all the options for disposal of bioplastics. That's again one of the disadvantage, because people will litter thinking that it will degrade, but not all the bioplastics are biodegradable. That is again a disadvantage. Yeah. So bioplastics are an assimilation of which of this?
So, you
Yes,
go
ma'am.
to, excuse me, to go to previous slide.
This one or the
No,
first one?
previous one, that all the methods you show, all the disposal methods you show.
The answer to the question?
Yes, answer to
Yeah, here. Yeah.
the methods of disposal, but which one is better?
Better in the sense, if it is compostable, we have to use it in the composting unit. But it in the industrial composting unit, which will be better.
Oh,
But
industrial
how
compost.
to collect the bioplastics in a separate manner? Because people will keep plastic in the recycling bin, or if they know that is a biodegradable bioplastic, then they will keep it in the green bin, which is the organic waste bin. Then it will end up in composting plant. But if it end up in the blue bin, which is recyclable bin, then it will go to recycling facility, or finally end up in the incineration plant also. So we have to think how to collect this plastic, then only we can think about the disposable option. So if it comes along with the municipal solid waste, then we can easily decompose in the composting unit. So our project was like that, how to decompose the bioplastic along with the municipal organic waste. That's what we have studied. So it's given 90% degradation along with the municipal solid waste. But within that stipulated period, low time, organic waste got degraded, domestic waste. But this bioplastic taken some longer time to degrade. So this degrading property we have to enhance. That's the future scope. Then we can do any of this option. Yeah. Bioplastic are an assimilation of which of these characteristics? Bio-based, biodegradable. So option B is correct. Oh, sorry, you have to answer this question. Yeah. Can we? So here you can say this is a good bioplastic, made up of renewable resources and having degradation property. All the biodegradable plastics are compostable. True or false? You can answer. All the biodegradable plastics are compostable. Option A and B. Yeah, it's false. But all the compostable plastics are biodegradable. It's a subset of biodegradability. Yeah. Bioplastic refers solely to, here it's normal. Biodegradable plastic refers solely to biodegradable or composting plastic made up of natural material. That is again true or false. This is different from the last question, I guess. Yeah. Refers solely to biodegradable or compostable plastic made up of natural material. Here it's false because it's not solely refers to biodegradable or compostable plastic made up of natural material. Can be from petroleum based plastic also. Yeah. Then photobiodegradable plastics are a part of bioplastic. True or false? Yeah, it's true. Yeah, it's true because it's having uh, light sensitive additives, photosensitive additives, sensitizers like diketones, ferrozins, amino alkyl ferrozins. These are all photosensitizers which will enhance the UV degradation process when exposed to sunlight. It will, if it is a winter season, then again this won't work. Photodegradation won't work. And based on geography, if it's a chill climate having no sunlight, then it is again a problem. Then dirt or water cover. If it is the plastic is covered with some dirt or any water, then again it won't be degraded. Whenever the UV light passes, then only it will degrade. Or any shading. So these are all the problem with the photobiodegradable plastics. Yeah, we have discussed the Vegas products having a good thermal property from withstand minus 25 to 220 degrees, which is true. Product containing for PDCs are biodegradable. It's false. It's biodegradable. Yeah. Hope is clear. If you have any question on bioplastics and bio alternatives to plastic, you can unmute and you can ask. If you don't have any question, you can leave the meet. Thank you so much for joining the meet. And hope you have attended Rajesh live session also, and it will be useful. We may have another one session after the 8th week also. I think so. Yeah. Tomorrow is the deadline for week 7 assignment. Please go through the assignments. Thank you so much. If you don't have any question, you can leave the meet. Thank you so much. Yeah. I'll end the meet. Thank you.